To the students, viewers across Kenya and the world at large, good morning and welcome to the Watchman Chemistry Center. Here we are going to dismantle, to debunk, to devise, to disseminate in order to demystify that chemistry is one of the simplest subjects a student can score high marks. I'm your chemistry teacher, the Watchman Teacher Fabian. Fabian is a trained security guard who has worked with KK Security for the last 13 years. Besides that, I'm a trained biology chemistry teacher who is TSC compliant. Chemistry being one of the STEM subjects, STEM meaning sciences, chemistry is a science, technology, engineering, mathematics, is one subject that a student is required to score high marks so that you can have a wide range of career choice. For example, you can pursue a course in medicine, you can be a chemical engineer, you can do forensic research, you can do analytical chemistry, and also you can be a teacher like myself here, your Watchman teacher. Now, to the topic of today, we are going to talk about the key pillars of chemistry. The key pillars of chemistry. Now, for students to score high marks, you have to understand first of all, which are these key pillars of chemistry? And also get to understand the concept and the content in those areas. So I'm going to list them. And number one, one of the key pillars of chemistry is the chemistry of reactivity series. This is an area which is taught in Form 1 chemistry. Then, number two, we have the chemistry of periodicity. Then, number three, we have the chemistry of salts. Number four, we have the mole. In fact, this is an area of concern because for very many years, many students, when they hear the word mole, I believe they have that narrative that now chemistry is very hard because of just this one, the mole. And I remember many years back, it was referred to as the mole concept, but the Kenya Institute of Curriculum Development decided now that this topic to be called the mole. And then the last area that you are going to talk about briefly is organic chemistry. Now, let us look at these 5 areas which we have listed here. Let us look at the benefits of understanding the chemistry of reactivity series. So when you talk about the reactivity series, this is where metals are arranged in order of decreasing reactivity. Let us list them here. We have potassium, and the chemical symbol for potassium is K, followed by sodium. We have lithium, we have calcium, we have magnesium, we have aluminium, we have zinc, we have iron, we have lead, we have copper, we have mercury, and then we have silver. Allow me to leave at that point without including gold, which is the least reactive in the reactivity series. However, it is important for our students to know also where carbon and hydrogen is placed in the reactivity series. And carbon is placed between aluminium and zinc. And then hydrogen is placed between copper and lead. So one benefit of understanding the chemistry of reactivity series is that it can be used to predict, this is number one, to predict reaction of metals with water. Reaction of metals with water. If you look at our reactivity series, you'll find that calcium and metals above calcium, when they react with the cold water, they form their respective metal hydroxide and hydrogen gas is liberated. For example, I'll take one example where I will use potassium, and then you react potassium with water, and the products are potassium hydroxide plus hydrogen gas. Remember, when you write an equation, you always ensure that the equation is balanced. So we can put 2 here for potassium hydroxide, and also you can put 2 there for water, and then 2 there. So our equation is now balanced. The same case applies to sodium, the same case applies to radium, and also calcium. Metals below calcium do not react with cold water. However, they react with steam to form respective metal oxides and hydrogen gas. Aluminium, however, reacts with steam, and when they react with steam, the reaction quickly stops because of formation of an oxide of aluminium, which prevents further reaction. Let us look at the second benefit. The second benefit of the understanding the reactivity series is that you can be able to know which metals will react with dilute acids. So, reaction of metals with dilute acids. And the essence of telling my students to know where hydrogen is placed is because of this reaction of metals with dilute acids. So you find that when metals which are above hydrogen here in the reactivity series, when they react with dilute acids like nitric acid, you can talk of hydrochloric acid, you can talk of dilute sulfuric acid, they form their respective salt and hydrogen gas. For example, I'll take zinc, which will be our example, and then we react the zinc with hydrochloric acid to obtain zinc chloride, which is a salt, and hydrogen gas. Then ensure your equation is balanced. So, having known that all metals that are above hydrogen can react with dilute acids, what does that tell you when it comes now to another benefit of the reactivity series, and that is preparation of salts? It tells you that copper cannot react directly with dilute acids. However, if you are preparing a sort of copper, what you need to do is that you heat copper in air to obtain copper 2 oxide, which is basic. And then from there, you can react the copper 2 oxide with and dilute acid to obtain a salt and water. Let us now look at the fourth benefit of understanding the chemistry of reactivity series. Allow me to move these key pillars of chemistry besides here. So the key pillars, we have the reactivity series, periodicity, we have salts, the mole, then we have organic chemistry. We can now look at the fourth benefit of understanding the chemistry of the reactivity series, and that is number 4, single displacement. Reactions between metals. Single displacement reaction between metals. You'll find that the raw ions of raw ranking metals in the reactivity series will be reduced from their solutions by the high ranking metals in the reactivity series. I'll take an example of a reaction between zinc and a solution of copper 2 sulfate. So if you take a zinc and then you react it with the copper 2 sulfate, you find zinc will displace copper from the solution of its ions. Then the third benefit, and this benefit is in regards to where carbon is placed in the reactivity series. And this is when it comes to extraction of metals. You find that some of the metals, that is zinc, iron, and lead, which are below carbon in the reactivity series, will be extracted from their ores by reduction. Reason being that carbon is above them in the reactivity series, and the carbon will act as a reducing agent. However, extraction of metals like potassium and sodium, which are higher in the reactivity series, will be extracted through electrolysis. Therefore, my viewers, those are some of the benefits of understanding the chemistry of reactivity series among other benefits. Now, let us look at the second key pillar of chemistry, and that is the chemistry of periodicity. So when I talk about periodicity, this will cover 5 areas. We have atomic structure, number 2, we have the periodic table. Then we have the chemical families. Structure and bonding. Structure and bonding. So basically, what we need to understand is to understand these areas under periodicity. When we talk about atomic structure, we are talking about the structure of the atom, which is made up of subatomic particles. And these subatomic particles, we have the protons, we have the neutrons, and then we have the electrons. The protons and the neutrons are found in the nucleus of an atom, while the electrons are found on the larger area of the atom. Then also, you need to understand the atomic number and the mass number. You need to differentiate between the two. The other area is the energy levels and the electronic arrangement of an atom. Then, periodic table. This will entail being able to write the first 20 elements of the periodic table as they follow in their order. Then also you are able to write the chemical symbols of these elements, and then the electronic configuration of these elements will help you also to be able to know their valences, because we know there are those elements that will react by gaining electrons, others will react by losing electrons. So whatever is lost or gained, that basically is the valency of that element. Then the chemical formula. If you are given 2 elements, can you be able to write the chemical formula using their valencies? Besides that, you should know the radicals. You list them and know their valencies also, because you can be given an element and an radical, and then you are told to write the chemical formula of that compound. And when you're able to write down the chemical formula of that compound, this basically will help you to be able to write a chemical equation which is well balanced with state symbols. So that is basically the chemistry of periodic table. Then we have chemical families. We have 4 chemical families. We have the group 1 elements, which are referred to as the alkali metals. Then we have the group 2 elements, which are referred to as alkaline heavy metals. Then we have the group 7 elements, referred to as halogens, and then the group O, which are the normal gases. Those are the chemical families we are talking about, and you should be able to know the atomic ranges and ionic ranges down the group. How do they differ down the group and also across the period in regards to the chemical families? Then lastly but not the least, structure and bonding. Structure and bonding is encompassed in this area of periodicity, because when a periodic table is drawn, you are told to a question will be posed where you are asked, using dot and crosses, show bonding between element F and element W. That's an example I'm giving you. So, if you are able to connect structure and bonding with periodic table, then definitely you'll be able to answer that question. Know the type of bonds that we have. That is the ionic bond. We have the covalent bond. We have also the native bond, which is a type of a covalent bond. You also need to know that. These ones I'm going to expound them in my subsequent lessons that I'm going to give to you, because now I will expound in details. The third pillar of chemistry is the chemistry of salts. Here basically we talk about the solubility of salts. And when we talk about the solubility, the key area that a student must understand is which salts are soluble and which other salts are insoluble. For example, we say that all chlorine salts are soluble, except silver chloride and lead 2 chloride. However, lead 2 chloride is soluble in hot water. So, if you know chlorine salts are soluble, these are the only 2 which are insoluble, then you'll be able to answer many questions related to chlorine salts. Then we say that all nitrates salts are soluble. So if you come across any nitrate salt, then definitely that salt is soluble. Then all sulfates and sulfites salts are soluble, except those of calcium, barium, and lead. So if you have calcium sulfate, that one is an insoluble salt. If you have barium sulfate, it's an insoluble salt. And if you have lead sulfate, that's also an insoluble salt. Then all metal oxides we have also metal hydroxides. And carbonates are insoluble. Note the difference now. We are saying the others are soluble, but these ones now are insoluble. Except those of potassium, sodium, and ammonium. So, the oxides or metal hydroxide and carbonate of potassium, sodium, and ammonium are soluble. Then all sorts of potassium, sodium, and ammonium are soluble. If you understand this concept that I've written here, then basically when it comes to solubility of salts, you'll be able to answer any question related to this, even in their preparation. The fourth key pillars of chemistry is the mole. And basically, this topic, it is important for each and every student to understand the concept and the content. Because it will feature in theory work and also in a paper 3 of chemistry. So, all you need to understand when it comes to this topic of the mole, you can talk of calculation on the number of particles. When I talk about the number of particles, here I'm talking about the atoms, I'm talking about the ions, I'm talking about the electrons, I'm talking about the molecules, and so on. There you can use the Avogadro's constant. Then you need also to be able to calculate the percentage composition by mass of an element in a compound. Then also, you must be able to calculate the empirical formula and the molecular formula, which is very simple. I always say chemistry is very simple. Then you must be able to calculate the concentration. And here we are talking about the molarity of solutions. The concentration and the molarity of solutions. Then something related with the atomicity and more and less volume. This basically it's about applying the concept of Geruzat's law. The third key pillar of chemistry is what you call organic chemistry. In fact, this is one of the areas that I like very much because it made me love chemistry. And here I talk about organic chemistry, I'm talking about the study of carbon compounds, excluding the oxides of carbon and the carbonates. We're talking about organic chemistry 1 and organic chemistry 2. When you get the concept from your teacher, when you are taught by your teacher, you don't need, to get worried about this area of organic chemistry. Because what you need to do as a student is you build what we call organic chemistry mind map. You build organic chemistry mind map. What am I saying when I say organic chemistry mind map? You know those reactions, those processes that are featured in organic chemistry. I can just mention, because I'm going to expound during my subsequent lessons, we are talking about combustion, we are talking about cracking of alkenes, we are talking about hydrogenation, we are talking about addition reactions, we are talking about dehydration, we are talking about decarboxylation, substitution reactions, esterification, fermentation, polymerization, and saponification. Those are the areas that you need to understand those processes, so that when you sit down with a pen and paper, then From a reference point, you can be able to build a organic chemistry mind map, capturing all these 13 processes where you are going to include the conditions, if any, the reagents that you are supposed to use in a certain process. Also, you can be able to write an equation in regards to that process. I'm going to expound this later in our next lesson.